Morning everyone. In the last class we have done Kirchhoff's laws and the introduction to the Kirchhoff's law was regarding to solve the complex circuits. So sometimes we are unable to solve the circuits with the help of Ohm's law, V is equal to IR alone. So we use Kirchhoff's laws. So what are these laws? These are of two types, KCL and KVL. We have done the introduction about KCL. What is KCL? It states that if there is a node in the circuit, if there is a node in the circuit, if there is any node, for example, this is the node, this is the node, this is the node, this is the node in the circuit. If there is any node, the currents approaching the node and currents leaving the load, the sum of all these currents will be equal to 0. Or in another way, we can say that the sum of currents approaching to a particular node will be is equal to sum of currents leaving the node. Sum of currents leaving the node. Is that clear? Do you remember that? Yes, sir. Okay, so this was the examples. These were the examples that we have done. So next is the Kirchhoff's voltage law. After studying this KCL and KVL theoretically, we will try to solve some numericals on the both these concepts. So this is KVL, Kirchhoff's voltage law. What does this law states? Kirchhoff voltage law is based on the principle of conservation of energy. What does that mean in context to the electrical circuits? This requires that total work done in taking a unit positive charge around a closed path and ending up at the original point is 0. The crux of this definition is that sum of all voltage drops around the loop is equal to 0. Let us say there is a loop of electronic circuit. Let us say this is plus minus 5 volt. This is plus minus 5 volt and this resistor is of 2 ohms and this resistor is of 4 ohm. Now what will happen whenever you connect this voltage supply with this resistor combination? What will happen? The current will start flowing through this circuit. Will the current flow or not? The current will start flowing from positive terminal of the battery to the negative terminal. What will happen then? There is a voltage source and there will be a voltage drop here, V1. There will be a voltage drop here and there will be a voltage drop over here, V2. Let us say this is resistor R1 and this is resistor R2. Kirchhoff's voltage law states that if this is a loop, this is a closed loop. If this is a loop, the sum of voltages in this particular loop will be is equal to 0. What does that mean? That means the combination of source voltage plus the voltage drops across resistors will be equal to 0. How? Because the source voltage will oppose these two voltages, I into 2 plus I into 4. It will be is equal to 0. So this will be the equation of voltage law. How this equation came into existence, we will come to know after you have understood this point. So are you clear with this concept? If there is any loop within any circuit, in that enclosed loop, the sum of all voltages will be is equal to 0. The sum of all the voltages will be is equal to 0. Is that clear, beta? Yes, sir. Okay. So this is the example of KCL and KVL. Let us say this is a circuit and there is a voltage source of 10 volts. There are three resistances of 10 ohm, 20 ohm and 40 ohms, and there is another voltage which is of 20 volt. Let us say this is a circuit. So there are two nodes, node A and node B. Now if we apply KCL at node A, what will happen? I1 is approaching, I2 is also approaching the nodes, and IB is the I3 is leaving the node A. What are you saying, Nabij? Representation शो नहीं हो रही थी अब होगी ठीक है. So all of you are getting the presentation view or not? Yes, sir. Okay. So consider this diagram. There are two nodes A and B. There are two nodes A and B, and you are being shown with the three currents I1, I2 and I3. So if we consider node A, if we consider node A, current I1 is approaching, current I2 is also approaching the node A, and current I3 is leaving. So the expression for this particular node by applying KCL would be A1 I1 plus I2 will be is equal to I3, or the current in the same direction will be taken as positive and current in the opposite direction will be taken as negative. So these both equations are true by using KCL. Any doubt, beta? Okay. Similarly, for node B, I3 is approaching, I1 is also leaving, I2 is also leaving in this way. Okay. So here the KCL, if we apply KCL, the expression will become I3 is equal to I1 plus I2. Any doubt? Okay. Now, for applying KVL, just remember KCL works on the nodes, KVL works on the loops. So how many loops are there? There are three loops. Loop number 1, loop number 2 and loop number 3. So how many currents are there and how many voltages are there in loop number 1? So the first voltage is source voltage, which is 10. The voltage here will be is equal to the voltage drops across resistor R1 and across resistor R3. So 10 will be is equal to I1 into R1. R1 is 10. I1 into 10 plus I1, I3 into R3. I3 into I3. 40 into I3. So this is voltage drop V1. This is voltage drop V2. This is the source voltage. In actual, मैं आपको ये दोबारा बना के दिखाता हूँ. In actual, what will happen is, so let us take an example of KVL. Let me explain you very clearly. So let us say there is a voltage and there are two resistances. So plus minus Vs, this is resistor R1, this is resistor R2. The voltage drop across resistor R1 is V1 and voltage drop across resistor R2 is V2. Let us see. Now this is the loop. This is the loop. Let us say current I1 flows through this loop. Let us say current I1 flows through this loop. So what KVL states is this, that the sum of voltages Vs plus V1 plus V2 will be is equal to 0. This is the concept of KVL. That means all the voltages within a loop and their sum is equal to 0. Now how this actually happens? So you have to consider the sign notations. So in this particular loop, let us say the current I1 will flow. Let us say the current I1 will flow. Now you have to remember, if this is a resistor and current flowing is in this direction, and you know always current flows from higher potential to lower potential. You know that? Current flows from higher potential to lower potential. So consider this is the positive point and this is the negative point. If it were a battery, it would have been like this. ये कैसी होती? ऐसी. ये अगर it were a battery, अगर ये बैटरी होती, ये वाला resistor, इसके across voltage drop होगा ना? So there will be a voltage drop across this resistor R1. So if we consider this voltage as a battery, if we compare it with the battery or voltage source, what should be the symbol? So there should be a positive at this end and negative at this end. Positive and negative. Now, this circuit is not true. I am only drawing this for your understanding only. Let us say This is the source voltage which is having in this direction, and the current is flowing in this direction from the resistor R1. The equivalent, which is the ambiguous or arbitrary battery, it will be having direction like plus and minus. Similarly, the current in the R2 will flow like this. The current in R2 will flow like this. So it will also develop polarity like this. That means it will also be having polarity like this. Any doubt? Positive and negative. Now if I combine all these batteries, what will happen? So these will be connected in this fashion. Do you understand what I have done? Okay, so let us say this is of 10 volt, this is of 5 volt, this is of 5 volt. Will all these voltages add or they will get subtracted? These two voltages will add because they are having same polarity, just like your AAA size cells, remote cells. So these two will add 5 and 5, they will become is equal to 10. But this is in opposite polarity. This is in this particular voltage is in opposite polarity. So if this is 10 volt, this will be minus 10 volt, and if we add these two, the overall voltage will be 0. Is that clear? Now you might have understood what I am trying to say is. Yes, sir. Okay, so again we should redraw the circuit. Just remember this thing is very important. If current is flowing in this direction, that means here the potential is positive and here the potential is negative within a resistor. Now we will take numerical values. Let us say this resistor is of 2 ohms. This resistor is of 5 ohm. This battery is of 10 volts. So by let us say current I is flowing through this. Current I is flowing through this. Now this is the loop and we have taken the direction of current in this particular direction. So now what is the direction of current with respect to this battery source? It is like this. So which symbol comes first? Negative symbol, there is a positive symbol. Which symbol comes first? We will put that symbol along with the numerical value of this. Okay, now current is flowing from this to this. The polarity across this resistor will be positive to negative. So it will develop a voltage drop which is equal to V is equal to IR. What is the value of R here? 2 ohms. So it will be plus 2 into I. Okay, now here the direction of current is again in this, and the value of loop current that we have taken is also in this direction. So it will also be positive and negative. So we will take this as plus 5 into I is equal to 0. So this is the crux of the discussion that we have done. This is the equation of KVL, and we can solve most of the circuits with the help of these KCL and KVLs. For example, here you can find the current. 5 plus 2 is 7. So 7I is equal to 10. I is equal to 10 by 7 amperes. So current in that particular circuit is 10 by 7 amperes. Now you can calculate the voltage drop for this resistor as well as for this resistor. You can take the screenshot of this and you can ask for any doubts. You are having 2 minutes for this. Yes, students, is that clear? Yes, sir. Any doubt in KCL and KVL? Now see this example. Now see this example. And are you getting this? There are three loops. Loop number 1, loop number 2 and loop number 3. Apply KVL and just understand, are you getting these equations? Equation number 1, 2 and 3. Are you getting these equations? Yes, sir. Any doubt? No, sir. Okay, now let us do an example. So, so we will be solving now an example of KCL. So you can write down, find out the power absorbed, find out the power absorbed in the resistors of the given circuit, in the resistors of the given circuit. Also assume I naught is 1 ampere. I am drawing the circuit, you can draw the circuit along with me. So students, this is the circuit and this is the question. What they are asking is, they are asking you to find out the power in each resistor. So how you can find out the power? The formula for power is, we have already done in the previous classes, the formula for calculating the power loss or power absorbed is I square R. That means you have to find out the value of I for each resistor. You have to find out the value of current for each resistor. So which law you can apply? KCL or KVL? KCL. KCL. So which law suits more here is because we are having the directions of current. So KCL will be more suitable. So just try to solve it. So this is a very simple question. So, so are you getting this? These branches these two branches are in parallel with each other. And if two branches are in parallel with each other, the voltage will remain same. So if we apply voltage across, let us say this is resistor R1, this is R2, this is R3. So the voltage across resistor R1 will be is equal to I1 into 1. P is equal to IR. But it is in parallel with this particular voltage source. So it will be 2 is equal to I1 into 1. So what will be the value of I1? I1 will be 2 amperes. Any doubt? 2 amperes. Any doubt, beta? No, sir. Okay. So similarly for the second resistor, VR2 will be 2 into I2. Similarly, these are also in parallel. The voltage will remain same, 2 into I2. So I2 will be 1 ampere. I2 will be 1 ampere. Any doubt? Similarly, no, I5 will be V upon R. It will be, if you solve it, it will be 0.4 ampere. So one thing I have missed in the question is you have also to find out the value of I. You have to find the value of I also. Okay. Okay. So apply KCL for finding out the value of I. You have to apply KCL. कहाँ पर KCL लगाओगे आप? At these nodes. At these nodes. So we can convert the diagram as, so can I draw this diagram in this way? Is there any difference? Okay. Now you are having the value of I1, I2 and I5. What is the value of I1? It is 2 ampere. 2 ampere. What is the value of I2? It is 1 ampere. What is the value of I5? It is 0.4 ampere. And you are having the value of I0. Apply KCL at node number Z, let us say. Apply KCL at Z. What will happen? The sum of approaching currents I plus I0 will be is equal to I1 plus I2 plus I5. What is the value of I? You have to calculate. What is the value of I0? 1. What is I1? It is 2 ampere. What is I2? 1 ampere. What is I5? It is 0.4 ampere. Now solve the value of I. Give me the answer. 2.4. So I is 2.4 amperes. So this is the application of KCL. And now what is left? You have to calculate power in each resistor. So power in resistor R1 is I square R, 2 square into R. What is R? 1. So it will be 4 watts. Power consumed by resistor R1 is 4 volts. Similarly, power consumed by resistor R2, it is I square R, 1 square into R. What is the value of R here? 2 ohms. So it is 2 watts. Is that clear? Similarly, power consumed for resistor R3, I square R, 0.4 square into R. What is the value of R? 5. Solve this for me. So what will be the value of this? 0.4 into 0.4 into 5. 4 by 10, 4 by 10, 4 into 4, 16, 16 into 5, 5, 6, 80. So it is 80 by 100. It is zero point 0.8 watt. 0.8 watt. Any doubt? Any doubt? Okay. Okay. Now we will continue in the next lecture, and then we will do the numericals on KVL. Okay. So I will send you photographs of the questions in the group. You can solve it by yourself. Is that clear? Okay, beta, that's all.